the coefficient of friction between the rod and the ground. Right, coefficient of friction. Coefficient of friction, let's just have a think about what we need. Well, friction, or maximum friction, is equal to mu times r. So the friction is happening at the point A, so I'm going to need to know two things. I'm going to need to know the reaction force at A, and I'm going to need to know the friction force at A, because those two things are going to allow me to find out mu. So, your three things, your checklist of what you're doing when you're doing statics: resolve vertically, resolve horizontally, do a moments. Well, we did a moments in part A. So resolve vertically, resolve horizontally is what we're going to do. So we're going to start off by resolving vertically, considering that all the forces acting up are going to be equal to all the forces acting down. And what tends to happen here is people go, oh, result, look, RA is acting up, 40G is acting down, so reaction at A must be 40G. Great. No. Here is where drawing the dashed line at the start comes into its own, because look, there is another force acting upwards, which is the vertical component of the reaction at C. So let's label that on there. We've got RC cos 15, which is acting vertically. So what I actually have when I'm doing my vertical resolution is I have the reaction at A plus RC cos 15 equals 40G. So all forces up equals all forces down. RC I've got stored in my calculator. So what I'm going to do is multiply that by cos 15, which gives me 228.5, etc., equals 40G, which is 392. And I'm going to subtract the 228 from that, which gives me that RA is 163.411, and again I'm going to store that in my calculator so that I can use it later on. So I've resolved vertically and I've found the reaction at A. What I now need to do is resolve horizontally, because what that will do is it will find me the frictional force here. Now, looking at this diagram, I've got frictional force acting to the right, reaction at A, 40G I can ignore because they're acting vertically, not horizontally. What I can't ignore is I've got another force up here acting that way, and that is the RC sine 15, which is going in this direction here. So what I have now is that I have friction equals RC sine 15. Now I had RC stored in my calculator from earlier, 236.65. I'm going to times that by sine 15, and that gives me 61.25 newtons. And it comes out exactly 61.25 because of the beauty of how trig interacts with each other. Let's not go into it, let's just accept that it's beautiful and magical. So, I know the reaction at A, I know the friction at A, I need to know the value of mu, the coefficient of friction. So I'm going to use that friction is mu times reaction. I know that friction is 61.25. I know that